after having a discussion about the surds, that is pure surd, then the mixed surd, then how to add, subtract, multiply and divide the surds, I want to tell you an important, very useful component which help you in all classes, that is the new term that is known as rationalization. Rationalization is like this, that is rationalization. Question is, what is rationalization and why it is needed? If I ask a question to you that cube root of 2 is what? You will say it is a surd. What kind of surd? Pure surd. Now, if I am looking for such a number which when multiplied this makes this surd as the rational number. It means I am asking you a very simplest form of another surd which when multiplied with the surd, the given surd makes this as a rational number. So this kind of searching of numbers or irrational numbers is known as the rationalization. Now the question is, how to trace such a number? You know, order of surd is what? 3. Order of this surd is 3. Order of given surd is what? 3. And radicand, or you can say base, the radicand is what? 2. The radicand is 2, the base is 2, and order is 3. So it means that what is the least number which when multiplied by cube root of 2 make this as free from roots, free from cube root, or gives the rational number. So if it is 3, then there must be how many 2's? 3 2's. Because order is 3. So I want how many 2's? I want 2 more 2's because 1 is already present in my surd. So if I say when cube root of 2 is multiplied by cube root of 2 into 2. Are you going to understand it? Yes. How? It is cube root of 2. This is the given surd. I am telling you that multiplication, division, addition, subtraction is possible only and only if order of surds is same. Now order of this surd is 3. So order of next surd which I want to multiply is also. In case of this, order of both surds is 3 and there was only 1 2, as order is 3, so I need 3 same type of prime numbers. So 1 is available 2, I need to multiply 2 more, so this can be written as in total together cube root of 2 into 2 into 2. So on multiplying 2 into 2 into 2, I just can say this is what 2 2 2 3 times 2 cube, and 2 cubes cube root can be written as 2 cubes power 1 upon 3 can be written as 2 cube into 1 upon 3, 3 cancel. What answer comes as 2. So answer of this part is a rational number, and the correct and the simplest number which is required is what? Cube root of 2 into 2. So this value cube root of 2 into 2 is known as the simplest rationalizing factor, SRF. So SRF of cube root of 2 is what? Cube root of 4. Because when cube root of 2 is multiplied to cube root of 4 gives us 2. So we can say what is the number which when multiplied with this cube root of 2 is what? Cube root of 4. As I shown you here, this is cube root of 2. When it is multiplied by cube root of 4, what answer is coming? 2. That is a rational number. Hence, the simplest term required to multiply with a surd is known as the rationalizing factor. That's why it is simplest, first one, hence it's known as SRF. Simplest rationalizing factor of cube root of 2 is cube root of 4, and simplest rationalizing factor of cube root of 4 will be cube root of 2. Now I am taking another example of rationalization. If I ask you what is the simplest rationalizing factor of cube root of 9? This is cube root of 3 into 3. 3 into 3. Here order is 3. So we need what? We need one more 3. So if I multiply it by cube root of 3, this will give me cube root of 3 into 3 into 3. So this gives us answer final as 3. So what comes? We get a number which is rational. So you can say the SRF of cube root of 9 is cube root of 3. And its reciprocal SRF of cube root of 3 will be what? Cube root of 9. Because when we know multiplication of A into B or B into A is same, that's why the SRF of cube root of 9 is cube root of 3 and cube root of 3 is cube root of 9. Now I am taking one more example where I will ask you to rationalize the denominator. Suppose I want to say that is 5 upon cube root of 16. 5 upon cube root of 16, bring it in the simplest form. Simplest form means there should be no irrational number in its denominator. So first of all, I will change this cube root of 16 in its simplest form, that is 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4. So this becomes 2 to the 4 to the 8 to the 16. Now this order is 3. So one of the pair of 3 same prime numbers will come out. So this can be written as 5 upon 2 into cube root of 2. 5 upon 2 into cube root of 2. That is 2 into cube root of 2 is the simplest form of this cube root of 16. Now the question is, we want to remove or we want to bring the denominator in the rational form, in the form of a number where denominator must be what? A rational number. So in order to remove this cube root of 2, what we need? Cube root of 4. So if I ask you to multiply numerator and denominator both by what? Cube root of 4. If I multiply by it what? Cube root of 4 in the denominator, then numerator will also be multiplied by cube root of 4. Now question is, why cube root of 4? The reason is because I have cube root of 2. There is one prime number 2. I need 2 more 2's under the same order. So 2 more 2's means 2 to the 4. So cube root of 4 into cube root of 4. This gives me 5 into cube root of 4 divided by 2 into cube root of 2 into cube root of 4 become cube root of 8, and cube root of 8 can be say as a number 2. So answer comes 5 cube root of 4 upon this is 2 into 2 become what? 4. So now the denominator is rationalized. So whenever any question is given to rationalize the denominator, we need to think for a simplest number. One very easy example, somebody says, what is the rationalized form of 3 upon, that is square root of 2. If you take this, you have to multiply numerator and denominator both by root 2. You will get to know that this is what? 3 root 2 upon root 2 into root 2 is root 4. Square root of 4 is 2. So this becomes 3 by 2 root 2. So this is the way when only single term in the denominator is given, then we can multiply it with its SRF. Now I will take the problems of the binomial terms in the denominator. Now I am taking few more examples where the denominator is not monomial, denominator is binomial. Meaning of monomial and binomial you must be clear. Monomial where single term, binomial where two term, trinomial where are three terms, more than three terms we say polynomial. Question is how to rationalize the denominator of 1 by root 5 minus root 3, second part 3 by root 14 plus root 11, third part 7 upon 3 plus root 8. So it is so simple to rationalize the denominator in case of the binomial. First part I am taking here 1 upon root 5 minus root 3. If I want to rationalize its denominator, what I need to do, I have to multiply numerator and denominator both by the conjugate of denominator. What is the conjugate? If I change the sign between two terms, here it is root 5 minus root 3. If I change the sign, I will get root 5 plus root 3. So I need to multiply it by root 5 plus root 3. Numerator is multiplied, that is 1 is multiplied. Then to keep the value same, denominator also multiplied with the same number. Now numerator 1 into root 5 become root 5 plus 1 into root 3 become root 3 upon in case of denominator you can observe it is a minus b, it is a plus b. I am taking root 5 as a, root 3 as b. So this becomes a minus b into a plus b. Algebraic identity a square minus b square. A square means root 5 whole square minus b square means root 3 whole square. This is coming as root 5 plus root 3 divided by root 5's whole square is what? 5. And root 3's whole square is what? 3. So answer comes as root 5 plus root 3 upon 5 minus 3, that is what? 2. This is the answer of the first part, rationalized. Now I am taking the second part. Similarly, the second part is what? 3 upon root 14 minus root 14 plus root 11. Now, in order to rationalize it, here denominator is also binomial. What is the procedure to rationalize the terms having the binomial as denominator? We look, we search, we find the conjugate. What is the conjugate? In the previous example, sign between two terms was negative, so conjugate was taken as positive. Here in the second example, the sign between root 14 and root 11 is positive. So I say the conjugate will be root 14 minus root 11. So this becomes 3 upon root 14 plus root 11 multiplied by root 14 minus root 11 multiplied by root 14 minus root 11 become 3 into what? Root 14 minus root 11. You cannot subtract root 14 minus root 11. Reason being, this is 14, this is 11. These are not the like. So, what is coming out to be a plus b, a minus b. This becomes a square minus b square, that is root 14 square is 14. Root 11 square is 11. So, answer is 3 into root 14 minus root 11 upon 14 minus 11 is what? 14 minus 11 become 3. This 3 and 3 cancelled. We get the answer is root 14 minus root 11 upon nothing, then you can say 1. So this is the second example of rationalizing the denominator. Now I am taking the third example. This is what? This is third part can be solved as 7 upon 3 plus root 8. Again very simple. Here the sign between two terms binomial is what? Positive. So what has to be the rationalizing factor with the sign negative? Conjugate. This becomes 7 upon 3 plus root 8 multiplied by 3 minus root 8 upon 3 minus root 8 becomes 7 times of 3 minus root 8 divided by 3 square minus root 8 square. This becomes 7 into 3 minus root 8 divided by 3 square is what? 9. Root 8 square is what? 8. So 9 minus 8. This becomes what? 1. So 7 into 3 minus root 8 is the answer of this part after rationalizing the denominator. Same type of question you can go for a lot of practice for making your math strong. Now I will tell you how to rationalize the term having 3 terms or the surds or the irrational numbers having 3 terms in the denominator, that is the trinomial type question. Now I am taking an example where I will explain you that how to rationalize a question where the denominator is trinomial. 1 upon 3 plus root 2 minus root 11. 3 terms. So I will make a pair of 2 terms. Suppose 3 plus root 2 is taken as one term and minus root 11 is taken another term. So the conjugate for this will be 3 plus root 2 minus root 11. So I am going to take these two as first and this as second. Change of the sign in the conjugate is required. So the conjugate will be 3 plus root 2 one term and then sign will be in place of minus will be positive. So this becomes 3 plus root 2 plus root 11 upon 3 plus root 2 plus root 11. Now 1 when multiplied, this will be 3 plus root 2 plus root 11 upon. This is to be considered as one term and this is another term. A minus b and a plus b, this become a plus b whole square, that is 3 plus root 2 whole square and minus root 11 square. This is a minus b, a plus b, a square minus b square. This becomes 3 plus root 2 plus root 11 upon 3 plus root 2 whole square, a square plus b square plus 2ab, that is 6 root 2. 3 plus root 2 whole square is a square, 3 square 9, root 2 whole square is 2 plus 2 into 3 into root 2 becomes 6 plus root 2 minus root 11 whole square is 11. I can tell you here 9 plus 2 is 11 positive and this is negative. So the answer of this part will be 3 plus root 2 plus root 11 upon. This 11 positive and negative will cancel. So there will be 6 root 2. Now 6 root 2's rationalizing factor is root 2. So now this 3 plus root 2 plus root 11 upon 6 root 2 needs to be multiplied with what? Root 2 into root 2. So what we will get? We will get that is 3 root 2. Then root 2 into root 2 is what? 4. That answer is 2. Root 11 into root 2 is what? Root of 22 divided by root 2 into root 2 is 2. 2 6 are 12. So this is the final rationalizing answer of a trinomial. Now we will discuss with you some application part of the rest.